Hi there, in this series of videos I want to explore themes and concepts that will help you in understanding your reading of quantitative research. In other words, it's not designed to allow you to do the research, do the analysis, etc., but more making sense of what you're reading. And in this first video I've entitled Describing Variables because I want to begin by exploring a lot of the language associated with quantitative research because I acknowledge that that can be a barrier to our understanding. But before I dive into that, I want to just take a step back and remind ourselves about the two broad areas known as research paradigms that exist out there, the quantitative and the qualitative. But I'm not implying that a piece of research has to be purely one or the other. You can, of course, have mixed method approach. But let's remind ourselves what these two paradigms broadly are. The qualitative research has the purpose of trying to understand, describe, and interpret both processes and phenomena in the real world as perceived and experienced by individuals, groups, and cultures. It's often referred to as exploring the lived experience of people, and I think that's quite a nice overview. On the other hand, quantitative research generates numerical values, in other words, data, through some sort of measurement of variables and analyzes these values to arrive at a conclusion. I will explore the meaning of this word variables shortly. Now we come across numbers in quantitative research and I want to reassure you that many of these numbers are quite straightforward. They may involve simple counts like sample sizes, percentages or measures of average. In other words, numbers that we are familiar with from our school days. But there are also numbers we will come across that are not familiar. And the two most important of these that I think we need to explore, not necessarily today, but to fully understand quantitative research, are the p-values and confidence intervals. In addition to this, however, the sheer quantity of numerical data presented in a paper can itself be overwhelming. Let me give you an example. Here's a paper I found from 2015 which uses a randomized control trial to investigate rehabilitation before major surgery. First we'll look at the abstract and then I want to show you two data tables that it shows further in. In the abstract, we see numbers appearing as a sample size, and researchers normally label this as N. So here we have 60 patients. We also see the subgroup gender expressed as counts and as percentages. So far, so good. Next, we see a mean age, which is just an average, followed by this curious plus or minus 9.56. Now, I have to point out that I later realised that that mean age of 8.10 was in fact a typo. It should have been 58.10, as you'll see when we come to the table. But interestingly, that plus or minus 9.56, that is an indication of what's known as the spread of the data. So not all participants were around 58 years old. Some were older, some were younger. And that 9.56 is a broad indication. We'll be devoting a later video to understanding things like measures of mean, measures of spread. Finally, we see our first, I think, genuinely difficult concept, this idea of the confidence interval. Now it's written as CI 95%, which means the 95% confidence interval, and they give us two values, a lower value and an upper value, and they're to be seen as limits. You see, what's happening is that in research, because we only have access to a sample, it means that what we're trying to get at, a population value, can only be accessed through an estimation, because our sample may have given different values if we collected from different participants. So this theoretical calculation, the confidence interval, gives us a lower and upper limit of where the population value might lie. And again, more about that later. Okay, the first of those two tables I promised. This is a table of what they're describing as baseline variables of the participants. Now you'll notice on the left hand side is the list of the variables, and in each case they give a clue as to what those numbers will mean once we come to look at them. So we have the mean and the standard deviation, that's what SD means, or we have the frequency and the percentage. In the groups themselves, they give the participant number. They're using that common convention n, so we can see we have an exactly equal group sizing for the two groups. They have a control group where there was no intervention, and they have an intervention group, which here they're calling expression group, but there are 30 in each group, and as you go down those two columns you can see the values of our participants starting out. So the mean, for example, for the age is in the expression group 54.4, which with a spread, a standard deviation of 10.8, and the control group, the average age, the mean age is 59.3 with a spread, a standard deviation of 10.45. This is why I realized in their abstract they had simply made a typo. You also have the frequencies occurring on some of these variables, and now that means we have to read those values differently. So frequency simply means a count. So here for the expression group we have 11 females. They don't need to give the males, we could just take that away from 30. That tells us there are 19 males, and in brackets that's that same value, that same frequency expressed as a percent. And again, I could get the value for the males by taking that value of 36.7 from 100. I won't bother doing that, but they're trying to be as brief as they can be. Even so, there's a lot of numbers here. As well as the confidence interval on the previous slide, we're now seeing that second concept I forewarned us of, the p-value. All I'll say at this moment in time is that it is an expression of a probability, and because these are the baseline variables where we do not want there to be any differences between the two groups, we do not want that to be a small value. The magic number we're looking for is 0.05, 5%, and mercifully here none lie below that 0.05, but again more about that concept later. For the second table, this is a table of their results, and suddenly it jumps off the screen. It is overwhelming the amount of data they are throwing at us. Now when you're reading research, I think it's very important to be focused on what information you want to extract. You're under no obligation to read every word and understand every number, because very often, as has occurred here, many parameters are being measured and you yourself as a reader may only be interested in a small number. But we just calmly look at what the table is claiming to illustrate. So here, table 2, we are told that it's giving the mean with the standard deviations for all outcomes, so that's a measure for each participant, and then a mean and standard deviation for the differences across groups. Remember, the groups were called the expression group and the control group, and additionally they're going to give us the 95% confidence interval. That is that final column. So we would just pick out those variables of interest and make sense of it as we will. I will need to say more in a later video about the difference between a confidence interval that occurs for a measure and a confidence interval that is describing a difference. And that is a subtle point which I'm not going to dwell upon here. But I would say, as my guiding principle, is perhaps with a highlighter on your printout, just start to zone in on those values that are of interest to you. Obviously, we need to do some work on understanding other aspects of this. Okay, as promised, I want to really focus on language. So let's think about variables. Now, this young man might have once upon a time asked us to all stand up. If we were in a class, we might be standing up and look around at our colleagues and observing one another's characteristics and attributes. If I said to you, okay, report back, what do you notice? In what way are we the same, and in what way are we different from one another? Well, there is quite a variety just on the surface. The thing that might make us all similar is that we're all students in the same classroom attending the same course. However, interest is normally focused on those things that make us different or that are different between us. We might notice we're of different heights and different weights and ages. We might report that there's a range of hairstyles or eye colours, fashion sense, ethnic backgrounds. If we knew each other a little bit better, we might speak of the different skills we possess, say creatively or in sport. If we started to look at people's medical notes, we could, in principle, start looking at the differences across the group in blood pressure, blood cholesterol levels, pulse rates, etc. In other words, the characteristics of interest across the group are things that vary, and that is why they're called variables, because they are describable or measurable characteristics that are not the same person to person. In fact, some variables are characteristics that can change within the same person over time. You won't have to think about blood pressure in a person from a resting state to an active state. So a variable is a characteristic which has the potential to not be the same from person to person. That's what makes it both interesting and a challenge to describe and to explain when we look at differences in those variables when we perform some sort of intervention. Now there are four important pairings of jargon I want to explore. Qualitative versus quantitative data or characteristics, discrete versus continuous data. I also want to explore something known as the hierarchy of data types. And finally, I want to explain dependent versus independent variables. We'll take these one at a time. Now the first one, qualitative versus quantitative data or attributes or characteristics. This is the final time I will dwell on anything qualitative. But let's explore this through some examples. So with the tennis ball, for example, a qualitative attribute might be its colour and a quantitative attribute might be its weight. For the banana, qualitative might be its flavour, whereas quantitative might be the average number in a bunch. I've used the word median here, which is one of the averages that we can measure. For the shoes, qualitative might be their level of comfort, whereas quantitative might be their size. And for the CD, a qualitative might be where I place this particular band in terms of my favourites. Quantitative might be the playing time. I think readily you can see the idea that qualitative is often subjective, quantitative a lot less so because of the idea of the quantitative being measurable, generating a number, and therefore typically it is a lot more objective. You would expect two researchers to agree on quantitative attributes and not necessarily agree on qualitative attributes, but in both cases I might still describe those attributes as variables or as data, and I think it is valid to do so. But in quantitative it always becomes a clearly defined numerical attribute. Okay, the second concept was discrete versus continuous data, and now I'm talking only about quantitative data. Discrete data can only take certain permitted values, such as the number of children in a family, your shoe size, the calendar year. Now, generally, though not always, these are expressed as whole numbers called integers. Whereas continuous data can take values in between those whole numbers. In other words, they can be measured to an ever greater level of precision. All numbers in between the whole numbers could in theory be accessed and therefore reported. This is why if you see decimal points, it's usually a telltale sign of your data being continuous. Let's see some more examples to help. So with the book, for example, a discrete variable might be the number of words. It's an exact whole number, or it could be the number of pages or the number of chapters. Continuous might be the weight of the book, and you'll notice here I've expressed it to one decimal place, but in principle I could have expressed it to a greater level of precision, perhaps 2 or 3 decimal places. For the mobile phone, an example of discrete data could be the number of contacts in the address book, whereas the continuous data might be the frequency of the electromagnetic waves that I use to communicate between phones. And finally, for the CD, an example of discrete data, discrete measure might be the number of tracks, whereas continuous might be a measure of the width of the grooves here in micrometers. It's not necessarily true that continuous data has to have decimals. What's more important is to recognize that continuous data can in principle be measured to a greater level of precision. I'm using the word here precision not just to say I haven't made a mistake, but to have a finer and finer resolution, as it were. That concept doesn't readily cross over to discrete data. If I have a family with 5 children and someone says to me, well, give me that value more precisely, it's still 5 children. But if you say what is their average weight, then I could measure it to greater levels of precision. Okay, the third concept is this thing I've called the hierarchy of data types. It turns out, unsurprisingly, that not all numerical data types are of equal sophistication. This hierarchy of data types is conveniently divided into 4 groups. On the next slide, we'll see what those 4 types are, and then I'll show you some examples. So the least sophisticated is known as nominal. In some textbooks, particularly American ones, it's also referred to as categorical data. Then the next up is ordinal level data, and then we have interval level data, and finally ratio level data. Now some textbooks will collect those top two together and call them scale because they feel that they are very similar, and indeed they are very similar. So that arrow indicates moving from the least sophisticated to the most sophisticated. A quick description of each. Nominal level data is data that can only be categorized. So example, males versus female, what football team do you support, what political party did you vote for, and therefore the only meaningful number that can come out of nominal level data is a count. How many boys versus girls in the class, how many people voted Labour versus Conservative in the last election, that kind of thing. Still, it is a number, but it is only rudimentary in what we can do with it. Ordinal level data might still have a category aspect to it, but now you can naturally rank the data. So you imagine you're in a class and you've taken a test, it might be your ranking from first, second, third, right down to last. Typically when we're given these questionnaires to fill in and we're asked to put a tick by one of the response boxes about how you feel about something, it could be disagree strongly, disagree, neutral, agree, and agree strongly. There's a natural order to the responses. So researchers, statisticians will code this data by assigning numbers. Those numbers might be 1, 2, 3, 4. They are not claiming the numbers have any intrinsic meaning in their own right, but certainly those numbers do have a relative meaning. One can perform certain limited statistical analysis on that. The top two, interval and ratio, are variables where finally we can say this is an actual numerical measure. So interval level data is data with what I'm calling an arbitrary zero, e.g. degree centigrade. This arbitrary zero business is because for degree centigrade, for example, back in the day they decided that 0 degrees was when water froze and 100 degrees was when water boiled. But that could have been a different material they used, for example the freezing point and boiling point of alcohol or any other choice of material. This is what we mean by arbitrary. Whereas ratio level data is data where the 0 really means 0. Another way of looking at it is to say interval level data can go negative, whereas ratio level cannot go negative. With interval level data, it is the interval, the difference between two values, that have meaning. So the difference between, say, 10 degrees centigrade and 20 degrees centigrade is the same as the difference between 15 degrees centigrade and 25 degrees centigrade. But if it is 10 degrees centigrade today and 20 degrees centigrade tomorrow, I cannot say tomorrow that it is twice as hot because of that arbitrariness. Whereas with ratio level data, such comparisons are meaningful. So the ratio, the multiplying comparison, would make sense. So if one stick is 100 centimeters long, another stick is 200 centimeters long, you could say the second stick is twice as long as the first stick. Let me hopefully help that with some more examples. So with nominal level data or categorical level data, we might have groupings along the lines of hair colour, or we might have groupings along the line of gender and then populate that with counts. With ordinal level data, it might be, as I've said before, our position in a class test, or it could be one of these Likert type questions where I tick a box as to how much I love a particular subject. Interval level data, as well as the degree centigrade, you could have the Western calendar, AD versus BC. BC meaning effectively the minus numbers and AD meaning effectively the positive numbers. You could have height above sea level. So the height of a mountain, for example, is not measured from its base, but it's measured from that line referring to the level of the ocean, whereas the mountain itself might extend below sea level. That, again, that sense of the arbitrariness of the zero. And finally, for ratio level data, you could have the birth rate of a child, you could have the distance between 2 points, etc. Okay, final concept, independent variables versus dependent variables. Now these are typically labels that have meaning when you have an actual intervention, so they will be relevant in a randomized control trial and those sorts of experiments. They may not always be as relevant for an observational study, but let's try and understand what they mean. Independent variables, well, these are usually the grouping variables, and therefore, to a large extent, they are groups that the researcher chose to focus on, and therefore, to some extent, has some control over. A couple of examples might be gender or type of exercise, or another example might be the amount of exercise. Now, I'm not claiming that the researcher assigns the gender to each person, but certainly would decide that gender is an important attribute they want to explore, and therefore would break up the groups according to gender, or break up the groups according to the type of exercise that people report doing. It is the variable, often a nominal level variable, which the researcher has some sort of choice over in their design and therefore has control over. Now let's compare and contrast to the dependent variable. The dependent variable is usually the outcome variables, because there may be more than one of these, and these are the variables which we are interested in seeing perhaps changes or differences across groups depending on our intervention. So we could be looking at their change in their heart rate before and after exercise, or changes in their BMI before and after a dietary intervention. In other words, it's the variable which the researcher herself is interested in studying, has to measure, and therefore wants to discover any relationships that may occur between its value and the grouping variable. I want to give you 3 examples. The first example might be where I'm interested in any differences in average birth weight in a particular region between boys and girls. So my independent variable would be the gender, and my outcome variable, my dependent variable, might be the birth weight. Another example might be where I'm looking at people's levels of well-being during isolation. So my independent variable might be the days spent in self-isolation, and the outcome variable, the dependent variable, might be their level of happiness or some other measure of their well-being. This final one is a bit less likely. Pause the video and see if you can predict what the independent variable might be and what the dependent variable might be. Okay, I think that's enough for our first video. I hope that has been of some use, and of course we have to continue further exploring attributes of the research paper, but hopefully that was a reasonable start. Thank you very much.